So today we're going to be naming ionic compounds made of monatomic ions. And what are monatomic ions? Monoatomic ions, okay, are anions made of one nonmetal. Monoatomic ions. For example, fluoride, see, is a monatomic ion. See, when you have that in one formula, that's a monatomic ion. Oxide is a monatomic ion. If remember that we're talking about ionic compounds and during non-ionic compounds, the metals, they're gonna be like losing the electrons, while the non-metals, they're gonna be accepting them. And look over here at the chart of the atoms. See, you have -1 and -2 because that oxidation number is showing you the amount of, it's showing you the chart of the ion after, or the atom after losing or gaining that amount of electrons. When we're talking about monatomic ions, we are talking about only one type, okay, or one element that is a nonmetal involved in that ionic compound. If we have over here another example of a monatomic ion, and as you can see in there, you have only one non-metal. How are we gonna name, okay, ionic compounds that are made of monoatomic ions? See, let me start with the first, okay, example over here. So your first step when you are naming ionic compound is just to look at the metal. Look at the metal over there, and then you're gonna ask yourself, if this metal in group 1, 2, or 13, if the answer is yes, you don't have to worry about the oxidation number, and then you're gonna write the name of the cation. As you well know, the name of the cation doesn't change. Then, when you're done with that, you're gonna look at the non-metal. Do you have a monoatomic ion? Okay, yes, because you have only one non-metal. How are you gonna name that non-metal? You're gonna drop at the ending of the element's name, and then you're gonna add IDE. Nitrogen, you're gonna drop the ending, and then you're gonna add IDE. Okay, let me see, I have another example here. Okay, see, you're gonna analyze the metal. Is the metal in group 1, 2, or 13? If the answer is yes, the name of the cation. If the name of the cation never change, then you're gonna look at the non-metal. Do I have a monatomic ion? Answer is yes. Okay, you are gonna drop the ending of the element's name, and I'm gonna add IDE. That number there, that number that you have there, that doesn't mean that you have two non-metal. That means that you have two atoms of the same element. Okay. Miramos, but what is gonna happen if I have an ionic compound that is made of a monoatomic ion, but still I don't have a metal that is in group 1, 2, or 13. And I'm gonna start with the most common one. Okay. So you're gonna follow the same step. You're gonna look at your metal. Is your metal in group 1, 2, or 13? If the answer is no, okay, you're gonna ask yourself, do I have to worry about the oxidation number? Yes. Okay, and then you're gonna proceed. I'm gonna name the metal, okay? If the metal is the cation is gonna change the name? No, I don't. But since you have to worry about the oxidation number, you're gonna open a parenthesis. And then you're gonna continue the same procedure, same step. Do I have a monoatomic ion? Yes. Okay, what do you do to name a monoatomic ion? So you drop the ending, okay, and then you add, or the element's name, and then you add IDE. Miramos, how we're gonna find that oxidation number. And I'm gonna use the mathematical approach. Because that way you're gonna be practicing for the SAT. Okay, so 2 over here is the number of atoms of ions that are involved in that ionic compound. Do you know the oxidation number of iron? No. Okay, plus 3 atoms of oxygen are involved in that ionic compound. Okay, Do you know the oxidation number of oxygen? Yes. And if you have a periodic table in front, of you, you will see that oxygen is in group 16, 6 valence electrons, so it needs to gain 2 more to reach chemical stability. So in order to be a compound that is stable, okay, the addition, see, of the share of the cation has to be equal to 0. And then you have an equation here. See, if you're taking this class, that means that you already took algebra 1. So if you're taking algebra 2, you don't know how to solve a multi-step equation, you're in trouble. Because you're not going to be able to get a good score, a decent score next year on the SAT. Okay? So I'm going to solve my equation because I'm looking for the oxidation number of iron. First, I'm going to get rid of the 6 by performing the opposite operation. What is the opposite operation of subtraction? Addition. And then I have 2x equal to positive 6. The opposite of multiplication is division. And my oxidation number is equal to positive 3. Is that oxidation number reasonable? Yes. Okay? Because it is positive and I'm looking for the oxidation number of a metal. If the tendency of the metal is just to lose electron. Miramos, what am I going to do with this information? Yeah, I don't know if you learned this in 4th grade. I don't know if still that is part of the curriculum, but you have to know how to write numbers using Roman numerals. Okay, so 3 in Roman numerals, 1, 2, 3. And you put that over there. And that's the name of that compound, iron trioxide. Now, in this case, it's super easy. Why? Because if you undo, okay, this is your chemical formula. If you undo your formula, okay, you know that this 2 is coming from negative 2. And you know that this 3 is coming for positive 3. See, if you, instead of dance, you undo the formula, okay, you're going to be able to get that. Now, can you apply the undoing strategy in every chemical formula? The answer is no. That's what I'm using, the mathematical approach. Okay? I'm going to show you an example right now. Okay, let's say that you have this compound. It's an ionic compound because it's made of a metal and a non-metal. So I'm going to analyze my metal. Is the metal in group 1, 2, or 13? No. Do I have to worry about the oxidation number? Yes. But I'm going to start naming that compound. So iron is the metal, is the cation, but I have to worry about the oxidation number. So I'm going to open a parenthesis because in that parenthesis I have to put the oxidation number. I'm going to analyze then the non-metal. Non-metal. Do I have a monoatomic ion? Yes, because I have only oxygen in there. Okay? So I'm going to drop the ending. And then I'm going to add IDE. Miramos how I'm going to look the oxidation number. Mathematical approach. How many atoms of iron you have over there? If you don't have a subscript, that means that you have only 1. Okay, do you know the oxidation number of iron in that compound? That's what you're looking for. Plus, how many atoms over here of oxygen do you have in there? If you don't have a subscript, that means that you have 1. What is the oxidation number for oxygen? -2. Okay, continue with this. Okay, so you know that the oxidation number of oxygen is -2 because oxygen is in group 16. 16, 6 valence electron, 2 more to reach a electron in the last level of energy. And you know that that addition has to be equal to 0 in order for the compound to be stable. How are you going to solve that? I'm not going to teach you how to solve a multi-step equation because the majority of you are in algebra 2, analyzing functions, okay? So you already know how to do this. I'm going to get rid of this. And my oxidation number is equal to +2. Is this reasonable? Okay, yes. Why? Because look at the sign. If you get a negative number, is that answer reasonable? No, because remember, you are looking for the oxidation number of a metal, and the tendency of the metal is just to lose electrons, not to gain them. Okay, so what am I going to do with these two, Ms. Ramos? You're going to put that over here in Roman numeral. See that? See that in this case, the undue wasn't doing the trick? Okay. With that information, a ver, let me unmute Danelis, because Daneli was the one that was concerned. ¿Dónde está Daneli? About the assignment that I was putting on. ¿Dónde se me metió Danelis?
Yeah. Okay, hold on, let me find them.
Okay. And that's how the test, see, is going to be designed. Because if I give you the formula, you're going to copy and paste that on the internet to look for the answer. So I'm not going to give you the formula. I'm going to give you, see, the elements that are involved in that compound. And then you need to put them together. I was giving you lead plus 2 combined with what? Espérate, give me a second, Danelli, because it's not showing. And you were combining lead with an oxidation number equal plus 2. And when I was putting there the plus 2, I was letting you know that in that case, lead was losing 2 electrons, and lead was combined with what?
Oxygen.
Oxygen. Do I have to give you, okay, oxidation number for oxygen? No, because you're going to look down on the periodic table. Oxygen is in group 16, 6 valence electron, accepting 2 more, -2. And you know how to write the chemical formula from there. When you have the symbol and you have the oxidation number, what do you have to do? You dance, baby, you dance, no? Oh, Miss Ramos, but over here we can simplify that, or we can cancel the oxidation number. And over here we need to simplify. So the chemical formula is that one. That's the chemical formula for the ionic compound that is going to be formed. Now, you're going to look over here at lead. Okay? So, is lead in group 1, 2, or 17? Oh, you're 17. Is lead in group 1, 2, or 13? No, it's in group 14. Do I have to worry about the oxidation number? Yes. I'm going to open that over here. So, mono or poly? Mono, because I have only one non-metal outside. Oh, Miss Ramos, how am I going to find this? I was giving that to you. How many electrons was lead losing? Lead to oxide. Listen to me. There's another compound. Another compound made by lead and oxygen. That's not lead to oxide. See, this one is not lead to oxide. It's a different compound. Okay, by the way, is lead 4 oxide. How do I know the 4? Mathematical approach. You do that, multiply the number of atoms by the oxidation number. See, 1 atom, I don't know the oxidation number of lead. 2 atoms over here. The oxidation number of oxygen is -2, and that has to be equal to 0 because it's stable, okay, neutral, no charge at all, okay? So you solve that, -4 plus 4 plus 4, and that's how I got that 4 over here. Questions? No? You don't have any questions? Okay.